In this video, we'll learn how to solve word problems by translating them into systems of two linear equations. These types of problems appear everywhere from business to science to everyday situations. Let's outline our approach to solving these problems. First, we need to carefully read the problem and identify what we're looking for. Second, we'll define our variables. Third, we'll translate the problem into two linear equations. Fourth, we'll solve the system of equations. And finally, we'll verify our answer makes sense in the context of the problem. Let's solve our first problem. A coffee shop sells regular coffee for $4 and specialty coffee for $6. On Monday, they sold 30 cups in total and made $150. How many of each type of coffee did they sell? Let's start by defining our variables. We'll let X represent the number of regular coffees sold, and Y represent the number of specialty coffees sold. Now, let's translate the problem into equations. First, we know they sold 30 cups in total. This means X plus Y equals 30. Second, we know the total revenue was $150. Regular coffee costs $4 per cup, so they made $4X from regular coffee. Specialty coffee costs $6 per cup, so they made $6Y from specialty coffee. The total revenue equation is therefore 4X plus 6, Y equals 150. Now, let's solve this system of equations. We'll use the elimination method. To eliminate one of the variables, we'll multiply the first equation by -4. This gives us -4x minus 4, y equals -120. Now we add this to our second equation. 4x plus 6, y equals 150. The 4x terms cancel out, and we get 2y equals 30, so y equals 15. Now we substitute y equals 15 back into our first equation, x plus 15 equals 30. Solving for x, we get x equals 15. Let's verify our solution. We found x equals 15 and y equals 15. Let's check if these values satisfy our original conditions. First, x plus y equals 15 plus 15 equals 30. Check. Second, 4x plus 6, y equals 4 times 15 plus 6 times 15 equals 60 plus 90 equals 150. Check. So the coffee shop sold 15 regular coffees and 15 specialty coffees on Monday. Now, let's try another problem. A theater sold 750 tickets for a show. Adult tickets cost $12 each, and child tickets cost $8 each. The total revenue was $8,400. How many adult tickets and how many child tickets were sold? Let's define our variables. We'll let A represent the number of adult tickets sold, and C represent the number of child tickets sold. Now, let's translate the problem into equations. First, we know they sold 750 tickets in total. This means A plus C equals 750. Second, we know the total revenue was $8,400. Adult tickets cost $12 each, so they made $12 from adult tickets. Child tickets cost $8 each, so they made $8C from child tickets. The total revenue equation is therefore 12A plus 8C equals 8,400. Let's solve this system. We'll use the substitution method this time. From the first equation, we can express C in terms of A. C equals 750 minus A. Now, we substitute this into the second equation. 12A plus 8 times 750 minus A equals 8,400. Simplifying, 12A plus 6,000 minus 8 A equals 8,400. Combining like terms, for A plus 6,000 equals 8,400. Subtracting 6,000 from both sides, for A equals 2,400. Therefore, A equals 600. Now we can find C by substituting A equals 600 into our expression for C. C equals 750 minus 600 equals 150. Let's verify our solution. We found A equals 600 and C equals 150. Let's check our original conditions. First, A plus C equals 600 plus 150 equals 750. Check. Second, 12A plus 8C equals 12 times 600 plus 8 times 150 equals 7,200 plus 1,200 equals 8,400. Check. So the theater sold 600 adult tickets and 150 child tickets. Let's summarize what we've learned about solving word problems with systems of equations. First, we define our variables clearly. Second, we carefully translate the word problem into two linear equations. Then, we solve the system using either the elimination method or the substitution method. Finally, we verify our solution and interpret it in the context of the original problem. With practice, you'll become proficient at recognizing patterns in word problems and translating them into systems of equations. This is a powerful tool that can help you solve many real-world problems.